Welcome. This is 4.2 part 2. We're going to talk about upper and lower sums. So now that we've mastered the summation, we're going to use it in some problems. So let's look at this. We're going to divide the subinterval into n equal subintervals. That means how many rectangles we're going to divide it in. Now, the width of each rectangle is going to be a formula, and one that you have to figure out. It's b minus a over n. So that'll get you the delta x's, or how wide the difference is in the width of the rectangles. Now the endpoints, just to let you know, are, and let me get my stuff out here, is a plus 0 times delta x, which is less than a. So they're telling you it's in order. It goes up in number. And the lower sum, important now. This gets a box, it gets put in your notebook. This lower sum is the summation of 1 to n of f of the m of i's. That's the height of the rectangle. So the height goes to the function times the delta x, which is the base of the rectangle. Now the upper sum, that's lower sum. The upper sum is going to be a capital M of I. And I will explain that when we do a couple of problems. So I'm going to try to straighten myself out here with the camera. Sorry, I don't know if it's working. It's tough. All right, and I want to tell you that the region, the area of the region is actually an approximation, and it's between the lower sum and the upper sum. So let me kind of show you what we're talking about graphically. Graphically, we have an inscribed stuff, which would be a, if you notice, they go to the left endpoint because it's concave down. If it was concave up, it'd be different. But they go to the left endpoint, which means this will be an underestimate. And this is the circumscribed ones, which go to the right endpoints of all these rectangles. And that would be an overestimate. So we're getting the area somewhere in between them. Next. So we got our left endpoints and right endpoints. Usually we start at 0, but you'll get an example that doesn't start at 0. And it's going to be the 0 plus I minus 1, because we're starting on the left. So if we're starting on the left, we start at 0, or I minus 1, and we go up, okay? But if we start at the right endpoint, we moved a little bit in the rectangle. So we started a little bit over. So that's why it's just I times delta x. Right now, this seems a little hazy, and it's okay. I bet you all 30, some of you think it's the same thing. But watch when we do an example, it'll become crystal clear, or at least clear. So anyway, use 4 rectangles to find 2 approximations of the area lying between the graph y equals the square root of x, and the x-axis, and x equals 0, and x equals 2. So it told me, this is what we got from that whole problem. I got the square root graph, which kind of goes like that. All right, we're going from the x-axis, x equals 0 to x equals 2. So here is my interval right here. Okay, and the x-axis, it told me n was 4. We want 4 rectangles. So we're going to have b is 2, a is 0. So it's going to be 2 minus 0 divided by 4, so delta x actually equals a half. So my rectangles, when I draw them, if I do the lower sum, which is the left endpoint, okay, look at the first rectangle right here. And it goes to here, then we go up, goes to here, and they're equal rectangles. I don't know if I did this very equally, okay? I try, folks, I try. And there they are, 4 rectangles, 1, 2, 3, 4. Assume that the distance between them are the same. This is actually a half, because it told me every delta x is a half from right up here. So that's a half, this is 1, this is 1.5, that's 2. Or 3 halves, if you will. So far, so good. At least I'm making a little sense out of this right now. Now, I'm going to use the lower sum formula, which says you're going from I equals 1 to 4 of f of I minus 1 over 2 into delta x. Where the heck did I get that I minus 1 over 2? Well, if you remember this right up here, here it is. Left endpoint right there, I minus 1 over 1 over 2. So this little m of I is equal to I minus 1 times a half. And that's where I get that. So now we're going to use that in the function. So the function was the square root graph function. So it's going to be square root, just going to rewrite this, okay? And it's going to be the square root of I minus 1 over 2 times a half. Well, one thing I could do, now I'm just going to solve this. One thing I can do is I can bring this half out in front and just multiply it by half at the end. So I'm going to have a half times. Now when I is 1, I get 0. Plus, when I is 2, I get the square root of 1 half. Plus, when I is 3, I get my square root of 2, I actually get 1, because it's the square root of 2 over 2. Not square root of 2 over 2, but the square root of the fraction 2 over 2, which is just 1. And then plus, when I is 4, I get the square root of 3 over 2. And I go ahead and I calculate that, and I get 1.466. So that's the lower, over here, thank you. That's the lower sum. Let's now do the upper sum. So this was lower, just a reminder. Upper sum. Ooh, done the same way. Only now, this rectangle is the upper sum, so there's going to be an overestimate because we do something like this. These are really bad rectangles. Oh, I didn't even get there. Get out of here. I'll try it. I'm not very good at this. This is the worst thing I do. Okay, there we go. Overestimate, there's 4. This is still a half. This is still 1. That's still 3 halves. And this is still 2. So my delta x does not change. My delta x is still a half. However, what does change now, I left some stuff up here. Let me erase this. I had this rolling. Get this out of here. Done. Okay, that's homework, but let's get that out of here too. Hey, anytime I can erase homework, that's fantastic, isn't it? So here we go, I equals 1. Now, the only thing that is going to change is that m of I. So that m of I, the capital M of I, going up, 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 here we go, is just I times delta x. So that m of I is just I times delta x, so that's just I over 2, because it's I times 1 half. That's what delta x is. So now I'm going to do the function. I'm going to just rewrite this nice for I equals 1 as the function of I over 2 times 1 half. That's an I. Okay? Now, I'm going to take that, here we go, I'm going to take this guy outside. All right, and I'm going to get, oh, did I screw that up? No, I left it there. There it is. Okay, so it's going to be 1 half times, watch this. When I is 1, it's going to be remember I took that out, so it's going to be just the square root of 1 over 2. When I is 2, it's going to be just 1. When I is 3, it's going to be square root of 3 halves. And when I is 4, I guess I just get the square root of 2. Now, I want you to look at this. Important. Left and right. The only thing different, here's 0. Watch. Look at this. This was for the next 3 points. Well, look at this. Here's the 3 points, because we started at the left, we started at a different endpoint, and now this one's different. So when I started at the left endpoint's different. When I start at the right the point of the rectangle. The right one's different, but everything else inside stays the same. So once you've calculated for one, you can basically use this calculation, whatever you did up top, as one on the bottom here too. But when the smoke clears and your calculator spits it out, you get 2.173. So I know the area of the figure. The area of the figure is in between 1.466 and it's in between 2.173. That's a big margin of error. So you know calculus coming down the road is going to take that and it's going to say, hey, you know, we can get it even closer, if not the exact amount. So that's what we're doing next time. But I have one more question for you to try. So this is a problem I caught somewhere, and it says, consider the function and estimate the area between the graph and the x-axis. Notice, this one doesn't start at 0. That's why I wanted to show you this. This, I think, is 26 in the book. This one starts at 2. I thought I pressed green. There it is. Starts at 2. So remember on that one formula we had? I'm looking for my notes real quick. I don't know if I'm going to do this any better or worse. But on that one formula, I have delta x. It's 4 rectangles. So delta x equals. And let's go back to the delta x. Where is it? Here it is. B minus a over n. No problem. Same thing. B minus a over n. It's 1/2. Because I'm going from 4 minus 2 is 2. 2 over 4 is 1/2. It's not always 1/2. I'm telling you that right now. It's just easier for me to do 1/2. But then when I do the endpoints, check this out. This one looks like, I don't know what endpoint this is. Let me see. One of the endpoints. This one looks like the left endpoint. So this is little m of I. And remember, on the other page for the m of i's, it's where to start. So it's going to be 2 plus I times 1/2. So 2 plus I times 1/2, and this one's going to be 2 plus I minus 1 times 1/2. So it's where to start. So the m of I equals 2 plus I times 1/2. Okay? Why 2? Why not 4? I think that might be the ending one. I don't know. Let me look at the next one. I don't know. Hold on. All right, I'm good. It's not the whole thing. I got it. I got the problem. Little m of I is 2 plus I times 1 over 2. So this just becomes 2 plus I halves. And if you get a common denominator, that's where I get that. Yes, yes. So now, it's 1/2, because that was the delta x, times this squared. Ooh, where did the squared come from? Remember, this is the function. Okay? And now I just plug in when I is 1, when I is 2, all the way to 4, and then I do the same thing, but now for the big M of I in green, unless, you know what, I'll have you do that. You finish big M of I. That's what I want you to do. This is the small M of I, and you can follow my work. You are to finish the big M of I. And if you want the formula, oh, I've got it right here. The big M of I is the start, which is 2. Oh, I'm a screw up. This is actually doing the right endpoint. This is the right endpoint. So this is actually the big M of I. I want you to do the small, finish and do the smaller m of I. Because if you look at my formulas here, I just did this one. The big M of I on the right endpoint, you do this one. So it's going to be 2 plus, and remember to multiply I minus 1 times 1/2. And you try it and see what you get. And we'll compare answers tomorrow. And that's what I want you to do right here. okay? I did big M of I, which was 2 plus I times a half. The I times a half, you have to do the multiplication first. So we did that, got a common denominator, and that is the same as that.